once we are comfortable with polynomials and simplifying them and applying some exponent rules if we have to distribute as well, then we can get into multiplying some binomials together. So again, binomials, these are polynomials that have two terms, and when we multiply them, we're distributing them still, but in order to kind of keep track so that we don't do things more than once or that we don't forget about things, then when we're distributing them, what we use is a little bit of an acronym that's called FOIL. So you may heard of people say, I'm going to FOIL this, or we're going to be foiling these terms or something like that. All that means is they are distributing. And what FOIL is just an acronym that is telling us for the F is to multiply the first terms together. That's the very first distribution that's happening. Then the O, multiply the outer terms together. So these ones, the A and the D. Then multiply the inner terms for I, so the B and the C. And then the last terms together, the B and the D. So that this is a way to kind of organize and keep track that everything got multiplied and distributed properly. We didn't do anything twice and we didn't forget about anything. Okay. So there's a worked out example here, but I will do these ones at the bottom so you can see how this works. So if I try to FOIL this, then what's going to happen is I'm going to multiply the first terms together. So that's what the FOIL represents. So that means I would multiply 3x and 4x together. And when we're FOILing, we always add in between our terms. So our FOIL, F was first, these together, then O, outer terms. The outer terms are the 3x and the 2. So they're going to get multiplied. Then I'm going to add, always in between the terms. Then I have to do the inner terms. And if this has a negative, I just kind of lump that with the numbers. So I'm going to do a -1 times a 4x. And I'm going to always add. And then the last terms for FOIL are going to be a -1 and a 2. So this is kind of keeping track that I multiplied these together. Those are my firsts. Then I multiplied these together. Those are my outers. Then I multiplied these together. Those are my inners. Then I multiplied these together. Those are my last. So there's my FOIL, my FOIL. And I just need to do these little products and then collect them. So if I multiply these together, that's going to be a 12x squared plus a 6x plus a -4x. I'm going to use a bracket because I don't like having a plus and a minus right beside each other, so we'll simplify that in the next step. And then plus a, again, a -2, which means if I were to collect these, I only have a 12x squared, but these two are like, so I can collect them, and they are a +2x, and then a -2. So that has been properly simplified. It's been expanded, and all the like terms have been collected. With B, even though there's a 2 here, this is not an exponent rule because this is not a monomial. This is a binomial, which means this 2 doesn't apply to both of these. This is just a shorter way of saying x minus 2 times x minus 2. And then we would FOIL that. So I'd multiply the firsts together, add, multiply the outers together, add, multiply the inners together, add, and then multiply the lasts together. And when we simplify this, I'm going to get an x squared plus -2x plus -2x plus +4. So if I collect my terms, I should get an x squared. These are like. So that's the expansion then. And then with C, this is a binomial times a trinomial, so it's not quite foiling, but the same kind of idea. I want to make sure that everything is accounted for, so that x needs to get multiplied by each one of those, but then this 2 also has to get multiplied by each one of those. So if I kind of keep track of that, then I'm going to get this x times 2x, so those are my firsts, add x times -3x, then add x times 4, So that I did all three of those distributions for the first term. Then I'm going to add, and I'm going to do these bottom ones, 2 times 2x squared plus 2 times negative 3x, add 2 times 4. And when we simplify this, I should get a 2x cubed plus minus 3x squared plus 4x plus 4x squared plus minus 6x plus 8. And then we'll go through and we'll collect all of our like terms. The cube is all alone, so nothing happens to that. It's still 2x cubed. Here's a squared. Here's another squared. So collect those. Here's an x. Here's one that's just x. So collect those. And then the constant's all by itself. Okay. Now if we use this idea, then we can start looking for some patterns along the way. So here, all of these, and the first examples worked out, these are binomial squares, which means it's exactly the same term. This is what we did on the other page, multiplied by itself twice. And how we expanded this one on the other side, if we FOILed it, we already did this one, it looked like this. So we'll use that as an example. But if I try these other ones that are kind of new, if I did this is x plus 4 times an x plus 4. If I FOIL this, then I'm multiplying the x's together. I'm multiplying the outer terms, 4 and x, I'm multiplying the inner terms, and I'm multiplying the last terms, which if I collect, should look like that. And if you see over here, this is x minus 4 times an x minus 4. If I do the same FOILing that's there, that's an x times x, an x times minus 4, an x times minus 4 for the inners, and then minus 4 and minus 4. And you'll see that this one looks almost exactly the same as what happened here. The only difference, there was a sign that was different in between, and there was a sign that came out here. So kind of keep that in mind moving through this unit. For these, if I expand these, this is a 2x plus 6 times a 2x plus 6, which means if I FOIL it, I'm multiplying the 2x's times another 2x's. I'm multiplying 2x plus 6. And then I'm multiplying a 2x times a 6. And then I'm multiplying a 6 and a 6. And then when we collect, we're going to get this. And then you can kind of probably make the prediction of what this one's going to look like, because it's almost the same. The only thing is changing is the sign. But let's verify this. No, I don't want the squared that's there. We're expanding that, so another 2x minus 6. Okay, which means this is going to be 4x squared, the firsts, the outers, the inners, and then the lasts, and then collect. There we go. Same type of trinomial, the only thing that's different is that sign, so kind of keep that in mind. Now it's asking us to get some general rules. If I have a plus b squared, and if you look at it, it's already kind of expanded a bit for us. So if I expand all of this, then I'm going to get something like this, a squared plus 2ab plus b squared, because these are like, they can collect. Okay, and it says now use your rule to multiply, and then this should be an addition, otherwise it doesn't make sense. To multiply that, well, if we use this kind of general pattern, what that means is what's going to happen here is I could FOIL it like normal, or if I want to just take a shortcut, this is going to be whatever's here squared, so it's going to be an x squared. Here, it's going to be whatever's here squared, so plus 100. And then in the middle is twice the a and the b being multiplied, so twice an x and a 10, which means it's going to be 10x but doubled. So it's a shortcut, not that FOILing is really that difficult, but it's something to kind of keep in mind. And then same type of here, if we have a subtraction in between these, if we were to expand this out, this is an a squared minus ab minus another AB plus B squared. So this gives us kind of another formulaic way of doing this, where these almost look exactly the same. The only difference is the plus or the minus, and that was based on whether that was a plus or a minus. So if I want to expand this, I know it's going to be an x squared, a plus 100, and then in the middle is going to be minus 20x. And then these rules are basically what was going on up here, so you can go back and verify that. Okay. We also can see some patterns that are called differences of squares. If you multiply something that's called a conjugate with each other, and all a conjugate is are binomial terms where they have exactly the same terms, but one's adding and one's subtracting. So here I've got an x plus 2 and an x minus 2. If I were to FOIL these, then what I would get is this: x squared minus 2x, but then the inners are plus 2x minus 4. And if I collect these two that are like terms, they collect and they just kind of go away. There is 0. So that just gives me this. Same kind of thing here. X plus 5 and x minus 5 is going to be an x squared plus, no, it will be a minus 5x first, just for consistency. Then plus 5x, then minus 25. And when I collect these are gone. So that's going to be an x squared minus 25. If I look at these and I FOIL them out, I'm going to get an x squared minus 3x plus 3x minus 9. These are going to be collected out. And then these ones, the 2x minus 5 and 2x plus 5, that's going to be 2x and 2x is 4x squared. 2x and plus 5 is 10x. Negative 5 and 2x is minus 10x. And then minus 25. These collect out. So this is going to be a 4x squared minus 25. Now in general, when I'm multiplying these conjugates together, where it's a minus b and a plus b, let's fill that in. So one of them's adding and one of them's subtracting. And what's going to happen, these, I don't know why it doesn't photocopy well. What's going to happen is that these are just going to be this. It's going to be whatever a squared is minus whatever b squared is. So here, that was this squared is 4x squared, this squared is 25, and we're subtracting in between. Same thing here, that's an x squared, that's a 3 squared, that's an x squared, that's a 2 squared, x squared, 5 squared. And what is being created in each one of these is what is referred to as a difference of squares, because it's a difference, a subtraction of two perfect squares in every single one of these cases. And this is something we're going to really have to rely on moving forward in the unit.